When we usually look at making aquaculture more efficient, we think about genetics, or maybe automation, better hardware.
Right, new machines, that sort of thing.
But the stack of papers we're looking at today on tiger grouper farming, it points to a purely microbial solution.
It's such a fascinating pivot.
It turns out the key to hitting some major UN goals isn't a new machine at all. It's all about how you manage the water.
Yeah, we're looking at this document. It analyzes findings from sustainable aquaculture journals, and it draws this direct line from a single fish tank to huge global targets.
Things like zero hunger and responsible consumption.
Exactly. It's pretty amazing.
So we're talking about something called biofloc technology. And the mission for this deep dive is to really unpack how this system works for the tiger grouper and, why it's such a game changer.
Well, the thing that stands out immediately is that biofloc isn't just about filtering water. It's about treating the water as a living reactor.
Okay, let's get into the mechanics of that, because biofloc sounds a little, bit like a sci-fi blob.
It's actually a really clever biological hack.
So in a normal fish tank, fish waste creates nitrogen,
Right.
which is toxic.
And usually you just flush that water out, lots of it.
But biofloc completely flips that script. It manipulates the carbon to nitrogen ratio.
And this is the crucial technical bit. The bacteria in the tank, they need carbon to process all that nitrogen. So what the farmers do is add an external carbon source.
And it can be something as simple as molasses, which I just love.
It's that simple. You add the molasses, and these heterotrophic bacteria just go into overdrive.
They start consuming the toxic nitrogen, and then they clump together into these protein-rich flocks.
And that's where the magic really becomes practical. Those flocks, they're not just sludge.
They're food.
They're nutritious food. The tiger grouper actually grazes on them throughout the day.
It's the ultimate recycling loop. You're turning the fish's own waste, with a little help from bacteria, back into a protein snack.
And the data shows the fish thrive on it. The physiological impact is huge.
So what are we talking about here?
We're talking about significantly higher survival rates, mainly because the water quality is so stable. You just don't get those deadly ammonia spikes.
And that stability, that reliability, that has to be the bridge to that first big goal we mentioned. SDG 2, zero hunger.
Precisely. If you stabilize the survival rate, you stabilize the food supply. It means you're producing high-quality animal protein with a much, much lower risk of crop failure.
That's the definition of food security right there.
It is.
But the higher survival rate is really a byproduct of a much cleaner system overall, which I guess brings us to the environmental side of things.
Yes, and this is where it really clicks for SDG 12, responsible consumption.
The resource efficiency.
This is what really stuck with me from the analysis. To keep water clean, you usually have to exchange it constantly. Pumping fresh water in, pumping dirty water out.
A huge amount of water.
A huge amount.
Yeah.
With a biofloc, you drastically cut that down because the bacteria are cleaning the water in situ.
So you're not draining local aquifers, and you're not dumping nitrate-loaded water back into the local river.
Exactly. And then you have to look at the feed factor.
Because they're snacking on the bioflocs all day.
Right. So the dependence on commercial feed just drops. And commercial feed is incredibly expensive and resource-intensive to produce.
That's the aha moment for the farmers, isn't it? It's not just about being green. It's an economic win.
Totally. You're buying less feed, you're pumping less water, and you're getting more fish out at the end of the day.
It aligns the economic incentive perfectly with the ecological one.
It really proves that sustainable aquaculture doesn't have to be some kind of, charity project. It's actually the smarter, more profitable way to farm.
So a dual threat solution. You tackle the hunger crisis with better, more reliable yields.
And you tackle the resource crisis by literally closing the loop. It just emphasizes that we don't always need new resources. Sometimes we just need to look at our waste in a different way.
Which I think leaves us with a pretty big question to chew on. If a simple fish tank can become a self-sustaining loop where waste actually equals food, why are so many of our massive industrial food systems still operating as these straight lines from resource to trash?
A very good question.
Thanks for listening to this deep dive, and we'll see you next time.
All right, let's jump right in. What if I told you we could tackle two of the world's absolute biggest problems? We're talking water scarcity and economic instability with just one simple, elegant idea. Well, today we're going to look at a technology that does exactly that. It literally turns waste into farming gold.
Okay, so really think about this for a second. What if we could farm fish, a ton of fish, using way less water and creating almost zero pollution? I mean, really, what if we could produce more food more sustainably without draining our planet's precious resources? It might sound like something out of a sci-fi movie, but believe me, it's the core promise of the tech we're digging into today.
So what is this incredible game-changing innovation? Well, let's meet the star of our show, BioFloc Technology.
At its heart, BioFloc is basically this ingenious, self-sustaining little world, all inside a tank. You see, instead of treating fish waste like, a problem you have to get rid of, this system looks at it completely differently. It sees it as a valuable ingredient.
So here's how it all works. It's actually pretty brilliant. First, the fish do their thing. They produce waste, which is mostly ammonia. But then, and this is the key, a whole community of good guy microbes gets to work. They just start munching on that waste, converting it. And here's the magic part. That whole process creates what's called BioFloc. These are basically little clumps of protein-rich goodness that the fish can then turn around and eat. It's like having a tiny cleanup crew that also happens to be your personal 24/7 chef. Amazing, right?
Okay, so this elegant little biological loop, it has massive, and I mean massive, real-world benefits. And first up is a big one. It directly tackles our global water crisis. We're talking about something that aligns perfectly with the United Nations Sustainable Development Goal number 6, which is all about ensuring clean water and sanitation for everyone.
Just take a look at this comparison. It really tells the whole story. On one side, you've got traditional fish farming that often requires a constant flow of fresh water, a ton of it. And that process not only uses up a huge amount of water, but it also pumps all that fish waste out into our rivers and oceans. Now, look at the other side. That's BioFloc. The water is recycled right there in the system, so you hardly have to change it out. The environmental impact? It's contained, and it's incredibly low. It's a night and day difference.
So how does it pull this off? Well, a few key things are happening. First, because it recycles water, it drastically cuts down on how much we need to pull from our rivers and lakes. Second, that community of microbes, they're acting like a natural water filter, keeping everything clean and high quality. And of course, since the waste gets converted into food, it's not being dumped as pollution. This is what I mean by a game changer. It makes fish farming possible, even in really dry, water-scarce parts of the world. But hold on, the benefits don't stop with just saving water and cleaning up the environment, not even close. This technology is also an absolute powerhouse for economic empowerment. And that brings us to another critical UN goal, Sustainable Development Goal number 8, which is all about promoting decent work and economic growth. This chart really lays out the business side of things perfectly. Just look at that first bar, operating costs. Because the BioFloc itself becomes food, it slashes one of the biggest expenses for any fish farmer, the feed bill. Now, check out the second bar, fish yield. Because the fish are in this super clean, stable environment, they're healthier and more of them survive. That boosts the total amount of fish you can produce. So what happens when you have lower costs and higher yields? Well, you get what you see in that third bar. Bigger, more reliable profits for the farmer. It's a win-win. And that extra profit? It creates this incredible positive ripple effect. We're talking higher, more reliable incomes for farming families. It creates new, skilled jobs because someone's got to manage these systems and monitor the water quality. And here's something really important. Because you can do this on a smaller scale, it really empowers local farmers and strengthens entire communities. You're building a much more resilient food system from the ground up. So when you step back and look at the whole picture, you realize BioFloc isn't just some clever little science trick. No, it's a truly integrated solution. It's a genuine 2-for-1 deal. This table just sums it all up so perfectly. Let's just walk through it. Take the first feature, recycling waste. For our water goal, SDG 6, that means less pollution. Simple. For our economic goal, SDG 8, it means lower feed costs for the farmer. Boom. Okay, next row, retaining water. Environmentally, that conserves fresh water. Economically, it cuts the farmer's water bill. You see the pattern here? And finally, farming at a higher density. That means we use less land per fish, which is great for the planet, and it boosts yield and income for the farmer. Every single feature delivers both an environmental and an economic win. It's just so efficient.
At the end of the day, BioFloc is so much more than just a smarter way to farm fish. It's really a blueprint. It's a working, breathing model for how innovative thinking can perfectly align the health of our planet with economic prosperity. It proves that we don't have to choose one over the other.
And that, of course, leaves us with one final big question. If we can take something like fish waste and turn it into a valuable resource that cleans our water and fuels our economies, well, it really makes you wonder, doesn't it? What other things that we call waste are actually just resources we haven't figured out how to unlock yet?
What's the next waste-to-resource breakthrough that's just waiting out there to be discovered?
Welcome back. Today, we are discussing how BioFloc technology supports the Sustainable Development Goals, specifically focusing on SDG 1 and SDG 14. First, let's look at SDG 1. No poverty. BioFloc technology helps achieve this by saving costs. It reduces fish feed costs by 20 to 30% because the fish eat the natural flocks found in the water. This system also allows for high-density farming where farmers can grow more fish in small tanks. This allows them to earn more money without needing large amounts of land, helping low-income families start a high-yield business with low capital. Next is SDG 14, Life Below Water. BioFloc technology features a zero-water exchange system that recycles water and waste. This ensures that no dirty ammonia water is dumped into our rivers or oceans. Because it is a closed-loop system, it effectively prevents water pollution and keeps our ecosystems clean.